Now to give you a little review to help you prepare for the test coming up. Now, first of all, you need to understand the terminology and what we're looking for with regard to these statements, the if-then statements. So look, here's the deal. You have an if-then statement where you say, if this, then that. If P, then Q. Where P, the if part, is the hypothesis, and the then part is the Q. Okay? Now, the converse of that would be when you switch the hypothesis and the conclusion. So you would say, if Q, then P. And you can look back at previous notes to get some concrete examples. The inverse is when you negate the original statement. If not P, then not Q. And this little symbol here means not. Now, the contrapositive is when you negate the converse. So you go back to the converse. It was if Q, then P. The contrapositive is if not Q, then not P. Now, the law of syllogism is going to be this. If P, then Q. Okay, you have that statement. And then the next statement is if Q, then R. And then you can bypass the middle one. If P, then R. Okay. Now, remember how to do the two-column proofs for solving an equation, where you need to put down the steps for solving the equation, but you also put in the reasons. Okay? So if you use the law of distributivity, if you clear the parentheses, you put over there law of distributivity. Can't talk. Okay? Then you need to be able to write equations for lines. The point-slope form of a line, where if you're given a point and a slope, you can write it. And I've got it here. I've got them all listed here. The slope-intercept form. The slope-intercept form is when you just take the point-slope form and solve for y. Remember, parallel lines have the same slope. Perpendicular lines have negative reciprocal slopes. Okay. Now, the next thing, this is very important. This is very helpful. When we have parallel lines cut by a transversal, like here, you have these 8 angles formed. And we classify them according to corresponding angles. And I've got them listed here. Consecutive angles, alternate interior angles, and alternate, can't talk. I've got this cold. Okay, alternate exterior angles. And I've got them listed here. Now, here's the deal with these 8 angles. The pairs, each pair that you look at, they are either equal to each other or supplementary to each other. So, I've shown that here. Angle 1 is congruent to angle 5. Angle 4 is congruent to angle 8. Angle 4 is congruent to 1. Angle 8 is congruent to 5. You can see how I've got them here. But if you just know one value, if you just know, for example, if you know that angle 2 has a measure of 30 degrees, then you can find every other angle by either saying it's equal or it's supplementary to angle 2. Okay? So this is very important. Now, look, here's the deal. You can be asked to show that lines are parallel, or you can be asked to find, given that they're parallel, and you're asked to find the angles. But if you have a situation where you have, for example, if you have this angle is congruent to this angle. In other words, if you have a situation where 2 lines are cut by a transversal and the consecutive angles are congruent, then you know those lines are parallel. That's all you have to know. If you know that this angle is congruent to this angle, That's all you need to know those lines are parallel. Now, it's an if and only if, because if those angles are not congruent, if angle 2 is a little bit different than angle 6, if angle 2 is a little bit different than angle 6, then they are definitely not parallel. Angle 2 and angle 6 have to be the same. Angle 5 and angle 1 have to be the same. So that's something to keep in mind. So if you're shown two lines cut by transversal and you want to know, are these parallel? Well, look to see if the corresponding angles are congruent. Yes, they are. If they're not, no, they're not. Okay? Remember, we deal with different types of angles. Remember, a linear pair. A linear pair are supplementary. Okay? And then we have other situations, angle addition, like in this second figure over here where angle 1 and 2, they add up to 90. And you know it's 90 because, I've got the little symbol there saying the intersection is 90. We have vertical angles. Remember, vertical angles are congruent. Okay. Remember segment addition, where, if you can just add up, this is pretty common sense. If you want to know the length of AC, well, that's going to consist of the length of AB plus the length of BC. Now, there's also going to be a proof involving angles. So be sure you're familiar with, vertical angles and that sort of thing, and just the very basics of the two-column proof.